first. Mic check. Can everybody hear me okay? Not over the top, not too much. Up front, I hope you can hear me. In the back with the camera, it sounds okay, so we'll go from there. Let's get started. For the sake of catching up on the schedule, my understanding is, walking into the last presentation, that the keynote ran a little long this morning, so now we're now in full-blown catch-up mode. So we'll do our best. Thank you for the gentlemen before me for finishing up in a timely fashion, even though they were rushed. There we go. All right, skip past the obligatory slides. This is hopefully what you're all in the room for. If you're not on this flight and your destination is someplace else, now's your opportunity to run to the door. Nobody's running, so that's good. We'll get started. The focus today is to convey some information to you that I've picked up regarding lean project management, and the term was relatively new to me when I was introduced to it. So what I want to do is give a little bit of a story. This is actually my 10th year at Alliance Day. For the previous 9 years that I came to Alliance Day, I was with an integration company out of Houston, and enjoyed it thoroughly, learned a lot. I've been nothing but a LabVIEW developer. It's the only language I know, and I grew up in that traditional waterfall model of programming. About 3 years ago, I left that integrator to go work for a former client of mine. That client had been purchased by Schlumberger, who, if you're not familiar with them, is one of the world's largest oil and gas production service providers. Because they're the largest, that also means that they've got exposure to a lot of risk when the price of oil comes up and goes down, and vice versa. But last fall, I had the opportunity to attend a week-long training class on lean project management. And the reason for that is that, unbeknownst to myself and to a lot of people around the world, Schlumberger, although they're a large oil and gas company, also happens to be one of the world's largest producers of software. So they're really kind of a big software development house as well internally. The particular division of Schlumberger I was with was the Schlumberger Technology Center. And we developed not just hardware and oil and gas solutions, but software that went along with those. And I was responsible for one particular product and developing that. So, like I said, about 6 months ago or so, my manager came to me and said, for purposes of growth within Schlumberger, and it'll do you good on your next job, you should go work, or you should go take this class on lean project management. I thought, great, I'll do that. So promptly went and took that, enjoyed the heck out of the class, saw all kinds of new things that I had never understood before, never learned about, and then I came back and 2 months later was laid off. So I didn't think she literally meant in your next job you're going to use this, as in your next employer, but it did turn out to be a little bit of foresight that turned out really well. So I now work for a different integration company that I did before. I'm back at my roots of it, and I wanted to take some of the things that I learned there. It was great at Schlumberger. They were agile, they had continuous delivery, they had cadence, they had scrum, they had sprints, they had vertical slices, all these great concepts that I had never really heard of before, had an opportunity to apply in terms of my work as an integrator. And so when I went to Valentium, I thought, this is my opportunity to take what I've learned and apply it with a new company. And when I got there, I found out this is what I had. I was back to the traditional development V, requirements, design, develop, verification, validation. We're back in the same process. You're given a project at the beginning, you're given all of your requirements, you work on that project, you disappear for 3 months, 6 months, and at the end you come back with something that should pass all of the verification and validation protocols that you wrote at the beginning of it. And it's a big deal. It's important that you're able to execute something like this, because when you're working in an industry that is regulated, such as the medical device industry, and you're working on test systems for them, you want to be able to know that you've defined your requirements, you've met them, and you produce them. But it's not necessarily exclusive to employing some of the techniques that I learned through lean project management. But a lot of those techniques tend to be drifted a little bit more towards the agile philosophies and things like that. And I am decidedly in a non-agile environment. Even some of our clients who claim to be agile won't actually say the word out loud because of the environment in which they work. So my goal today is to introduce you to some of these techniques, and hopefully you walk away with 2 or 3 things that you want to go back to your place of employment and try out with your project teams. So where I work at and currently develop with is I've got development teams that are probably about the size of 2 to 3 individuals. My entire team is probably about 12 people. So we may be working on several projects simultaneously, but generally you've got a developer who's responsible for the development of the code, for testing the code, for deploying the code, and verifying and validating it at the very end of it. So I had to find a way to take these techniques and apply them in that environment. So that's what I'm trying to give you some learned experiences from that, and how I did it there, and then try to show you how you can apply them as well. So one of the first topics that we're going to talk about is the concept of levers and gauges. For those of you who work in the control space and even the test and measurement space, you're used to dealing with the idea of inputs and outputs, right? But if we look at an example, take a locomotive control center, you can see that there are absolutely tons of gauges in there for them to manipulate, either for controlling pressure of steam, controlling furnace temperatures, the rate at which certain processes run, etc. They've got a lot of different inputs to that system, and a lot of feedback to them as well, in the case of analog gauges, or just sometimes a gut feel of how things are going, you know? When I get into the wrong motion, the locomotive tends to shake a little bit differently if I hit a nice resonance speed or something like that. So what we need to do is understand that how we develop software isn't that much different than how a control system works. We have inputs to our process that we can use to manipulate how fast we develop software and the quality of the product that we produce at the end of it. And then we've got measurements and devices that give us a means of telling how is our process doing, how well is our team doing as developers. So what are some of the levers that we have available to us as managers of projects or managers of software development teams? What are some of the things that we can take and manipulate in our either work environment or in our process in order to affect the outcome of our deliverable, either positively or negatively? So two of them I have up here are scope and requirements. And so very often what I find is early on in the project, I'm pulled in as a project manager to establish and write the requirements for the project after it's been sold. So the salespeople meet with the client and they come up with a general understanding of what it is they want. But one of the first steps that we have to do in that waterfall design process is to go in and actually write the requirements, both system requirements and software requirements. And so that's your opportunity to affect the outcome of things. If you can write your requirements in such a fashion to where they keep the scope within a certain line, or define requirements openly enough to where they're acceptable to the client, but you can develop around them and keep flexibility in your design, you're going to be better off. So you can adjust that, and that's going to affect how your software development process goes, because the work that you're working on now becomes manageable. You can define the size of it and define the scope and the capabilities of the software that you're working on there. Another one that you have is the actual process itself. How do you go about things? Who is it that writes your requirements? Who is it that actually architects your code? What sequence of events do you do that? Do you do it in an iterative fashion? Because even in waterfall, you've got a traditional waterfall where you go beginning to end, but you can actually iterate backwards through those a little bit. If you go into requirements and realize there's something missing back at a system level, you can go in and manipulate those requirements, or as you develop, you can go back and manipulate those. So what is your process like? My process is defined by our quality management system. Our quality management system says you're going to follow these steps, and if you need to make a change, there's a managed change process that you go back through in order to manipulate. But think about things about who's on your development team, what resources do you have available. Sometimes manipulating the process might be, we need a dedicated quality control person, right? Somebody who's outside of it, who didn't write the code, who has an opportunity to look at what was written and evaluate it, not coming at it from the software developer's perspective. Or maybe it's all of my teams need to work in conjunction with one another. No solo people on projects. I don't want dependencies to where if one person leaves a project and has to go someplace else, the project is left hanging. So you think about your process and what can you do there, and what can you do with the composition of your team in order to positively affect the outcome there. And then how do we measure what we get back from that? What are the gauges for our process to evaluate how well we're performing? Is it the number of submissions that you have to your source code control weekly per developer? Do you just keep track of the number of VIs that they're submitting? Is it the results of code reviews? I sit down with a developer, and this particular developer, this particular project yielded, on average, 5 major bugs every time that we came in for a code review on it. And this is an indicator to me that something in the process isn't quite working. If I keep producing the same number of high importance bugs each time through, maybe something else needs to go back into and look at what your code standards are or what your guidelines are, or maybe reuse libraries and figure out something along those lines. But we can look at different items here to figure out the health of our process. How are we producing? Two of the big ones up here are your time and your budget, because these affect your business as a whole. A lot of you are likely in a role where you're interested in this because this affects your bottom line. How do I figure out how many resources I need to apply to something in order to complete it? How do I get better at estimating how long a project is going to take? How do I stay under my budget and deliver ahead of schedule, or on schedule at least? And so these are the metrics that are important to you, because these are the things that drive when you can invoice, how much you can invoice, and the satisfaction of your customer, ultimately the quality of what you produce. So one of the first levers I'm going to introduce you to is the concept of team programming. You may have heard of either mob programming or some other ones here. But the general idea being that if you've got developers working together, two sets of eyes are often better than one. Now, some people look at it and think, well, we know the old adage that I can't just take a project that's taking 8 times as long, throw 7 more developers on it, and it's going to be solved within a week. It doesn't scale linearly like that. It never does as much as you want to. There are some benefits of scale, though, that could come along with that. Having 2 developers on a solo project has got not only benefits in terms of the speed of development. I've sat down with one of my developers on a project recently. We got to a certain point where development was probably about halfway done. We sat down to do a code review. And that code review actually turned into a bit of a design and development session, where what we did is he started showing me what he was doing in the code, and I started making suggestions as we went along. And he started to implement a little bit of those, and then we realized, hey, wait a minute, if we do that, that affects this piece of code over here. So we jumped to that code and back and forth. And the two of us tag teaming back and forth, only one of us sitting in front of the keyboard actually programming, but both of us tossing ideas back and forth gave us a few advantages. The first was the opportunity to think outside of where you're thinking, right? When you're a developer, you get into a zone, and you stay in the zone as long as you can. But being in that zone often means that you miss things that are on the peripheral, right? You're thinking about this one particular task, this one class, this one object, this one interface that you're working on, without thinking necessarily about what the repercussions are to the other one. So if you've got a second person staring at the code while you're developing it, while they're not typing or mousing, the other developer's got an opportunity to think aloud, kind of, and say, well, if you do that, what's the impact here? And for this developer to say, no, that doesn't impact that because of this relationship. Or to say, oh, hadn't thought of that. How are we going to solve that problem? And go back and forth between the two of them there. The other reason that it's a reduction in overall speed, or an increase in overall speed or reduction in the time of development, is because the improvement in quality that comes along with it. You get not only catching bugs before they get a chance to make it out further into your code and get released and find them that way, but you can catch them early because somebody else sees them. But at the same time, you get better adherence to either your coding standards or your development guidelines that you follow along. Somebody is less likely to skip that, oh, I don't normally comment things like that, right? They're less likely to skip that if there's somebody else watching simultaneously with them, even if they're a peer, because that means that you've got to collude in order to do the wrong thing at that point. So what you end up doing is actually driving home principles that both of you recognize and both of you are expected to follow with regard to development of your application process there. It also turns into a teaching opportunity. I did this with a junior developer last week. We were approaching a deadline for delivery, and I sat down and watched him start making some changes as he went through it. We were discussing bugs that need to be fixed, and I was kind of giving some guidance on which way to go. And there were moments where, in order for him to learn, I had to bite my tongue a few times and just draw back and say, okay, let him do it, and then, correct, and vice versa. So there was an opportunity for him to learn by me making correction, but at the same time, there's an opportunity for me as a manager and a peer to gauge his development and how he's progressing. Because by the end of the second day of doing that, I came in to make a correction to something he was doing. We were discussing a problem, and he starts to make a fix. I was like, no, don't do it that way, dude. And I paused myself and realized that he was on the right path, not me. So there's a level of working out of that where you look at it and say, well, by golly, I think they've got it, right? I can see actual growth and development as they go along. So from a management perspective, even if you're not necessarily coding together the entire time, taking the opportunity to do it occasionally has got a lot of far-ranging benefits. Now, some of the things you need in order to accomplish this. First is you need an environment that's conducive to it, right? So you can do it in very brief sessions together. Sitting in somebody's cube might get a little bit crowded. For more extended sessions of this, for instance, if you've got a deadline coming up in a week, you're behind, and you really need to make sure you get after it, you can do like two of our developers did. They commandeered our conference room for 5 days, which was fine, except for the fact that we were missing our conference room for 5 days. And that was due to lack of space. Now, eventually, we cleared out some space, created a nice dark room. They could dim the lights in. They called it the cave. And there's a sign posted outside the door that said, "Beware, dragons, are within." It builds a bit of camaraderie to have people working together like this, an us versus the world mentality type of thing. We're going to go out there and get this done. But some of the tools that they need in order to accomplish that are, they need access to source code control, right? You need some way of exchanging information back and forth between the two of you, because nothing kills productivity and team communication better than having to zip up all of the data, put it into a file, bring it over here, and manually merge it that way. So make sure that you've got some sort of means of exchanging the data between the two of you. The other one is that you need to be able to make use, for LabVIEW, make use of the merge tool. And although I will say that the very first time I used it, it was a little bit of a painful process, once you get the hang of it, it becomes incredibly useful to be able to recognize what the differences are between two pieces of code from what you have and what's checked in the source code, and to merge and affect those changes positively. It improves your development process as you go along with it. Two other techniques that I'd highlight are, you should have some sort of common coding style guideline internally. Now, don't think of it as, I need a set of rules that defines everything that needs to be done. Start with a brief document. Maybe it's a rules of don'ts, right? Don't run these wires behind these case structures. Don't leave a block diagram uncommented. Or maybe it's a set of do's. Make sure that every case structure has got a label on it. Make sure that your local variables that are stored in shift registers are all at the top of your while loop, and your bottom one contains your error structures. Maybe it's a defined process, such as a reusable piece of code like the asynchronous messaging communication technique, the AMC, or queues. Whatever it is, pick something. Make that your standard, so that when two developers are working on the same piece of code together or exchanging that code back and forth, they've got a common set of expectations of what other people on the team are going to be doing. So before I move into more levers and gauges, I want to introduce an overall concept that comes with lean. A lot of people, when they talk about lean development, they hear about lean manufacturing, which is kind of where it originated from, is this idea of a push versus pull system. Toyota, I think, is probably the most well-known in terms of lean manufacturing. If you've ever had the opportunity to visit their Tundra manufacturing plant in San Antonio, it's a prime example of this. They have a schedule of what they're going to make that day, and they only pull in the material that they need to make that particular set of items in a day. Now, some people take it to one extreme of that and say that, well, pull systems are build to order, right? You would develop only software that's demanded and do it that way. And it starts with customer demand as the driver for what software you're going to produce for the day. And in manufacturing, the alternative is, I'm going to build on a set schedule of forecast and of what I think is going to be required, and I'm going to build that regardless of customer demand. And it's not as black and white as that. Instead, what it comes down to is that the real definition of a pull system, at least from what I've best understood it as, is a pull system is one in which each stage of your process has got defined work in process limits. And you're going to see WIP all over here. When I took that 1-week training course, for 3 nights I dreamed about WIP limits over and over and over again. Okay? And they're important to understand because that distinguishes the two systems. So if you're placing an explicit limit on what a particular portion of your process is going to be able to work on at one time, you're working towards a pull system there. Now, for project managers and developers, this is often an emotional reaction, right? When we get behind as a manager, or when we get behind as a developer, the instinctive reaction is, I'm looking at all the things that I'm not getting done, I'd better start some of those, right? And the problem is that as soon as you start some of those, you now have more work that backs up and builds up here, and I have to divert my attention to lots of different places simultaneously. So, as an analogy, talking about work in process, I realized around my household that that there is a defined pull system inside of my house, and that is the laundry, right? So I've got a backlog of work to be done, i.e. I've got a laundry basket, or with my case with 2 kids, I've got 3 laundry baskets of laundry that needs to be done. And often it is customer demand, I need that shirt washed because I'm wearing it tomorrow, and I knew about this for a week, but I didn't think about it until last night. So I need to start a load of laundry. So our second stage is we actually do the laundry, the washer, the dryer, and those might be two distinct stages. And then finally, you've got the laundry that is clean but has not been folded, or as my kids like to refer to it, their second closet, right? In the morning they go to the dryer to find out what they need for school as opposed to going to the closet. And so work can build up at any one of these stages prior to actually having all the laundry folded and put away. Now, there's some very built-in natural work and process limits for the washer and dryer stage of things. I can only wash one load of laundry at a time. I can only dry one load of laundry at a time. But there is an unspoken limit on the amount of laundry that can be cleaned but not folded and put away yet. And what distinguishes a push system from a pull system is a push system has a natural limit built in. How much stuff can I store on the factory floor waiting for the next stage of manufacturing? How much stuff can I fit in the hallway before I can't walk around the pile in front of the dryer anymore and handle it that way? But no pull system would ever allow you to have a work in process pile that large on purpose. Okay? So mentally in my head, I have a work in process limit of maximum of 2. For 2 loads of laundry can be done needing to be put away. And if I come up and I need laundry, I'm not going to start another load of laundry back here until I've got that work in process limit down below 1 in order to continue it as I go along. So the distinction between push and pull is whether or not you've got work in progress limits or work in process limits in place. One of the benefits of this is that if I don't have too many things going on at one time, I'm going to stop multitasking. Okay? Now, for years we've known it. Humans are no good at multitasking, right? It's why we don't text and drive. It's why we don't work on 2 or 3 different projects simultaneously. Because the actual act of shifting between those different activities takes away time. It takes time to unwind it. It takes time to start back up on the next one. And for software development teams, it's especially true. When we do software, it's not widget manufacturing, right? There's not a process of you just pick up and start back on step 1 of 15 as you go through it. It requires you to go through a design process. It requires you to think about it, to engineer a solution, to be somewhat artistic about it. It's a creative process as we go through it. And so that's often why you see if somebody's sitting in their key working headphones on, you'd better have an important question before you interrupt it. Because you get them out of the zone, it's going to take another 15, 20 minutes to get back in the zone. So your question better be important. There's a saying, I don't know whether to attribute it as a parable, an old wise man saying or something like that, but he who chases 2 hares catches neither. Okay? And so for these purposes, one of the reasons we set work and process limits is to avoid putting our developers in a position where they're forced to switch between tasks multiple times as they go throughout the day. Now you can still put a developer on multiple tasks, but my recommendation to you is try to do that a little bit more on a weekly basis. Okay? Try not to have them switching multiple times throughout the day. Dedicate some time throughout their week to where you're going to work on this task and then work on the next task as you go. So a concept that I don't necessarily think is unique to Lean, but is a Kanban board or Kanban. I'm not strong enough in opinion to tell you which way it's said, but I know it's spelled K-A-N-B-A-N. But the concept of it is, and you've probably seen these before for projects, is you've got a list of tasks, right? You post-it notes, it can be on a whiteboard, kept in an Excel sheet, something like that. And we've got categories of work to be performed here. So we've got our backlog, which is our to-do list. What are the features that we need to implement for our product? What are the products that we're going to be delivering if they're small enough to be considered of that size? We're in the planning stage. In my case, have I written a product realization plan for it? Have I written the requirements for it? Have I done the software detailed design for it? Am I now in development with it? Have I gone through verification, validation? So my QMS system builds out a natural 7 or 8 different stages for me as you go through here. And yours will be unique, but you create for yourself different categories of work throughout your process. And then each task, as you finish it in one category, you move it over to the next one. But for work and process limits, what we do is we say that for each of these categories, we define a limit. I'm not going to work on more than 6 items at development at a time, which means that if I finish the planning stage there, and my planning stage is limited to 2, I don't move that item that I just finished planning into development until I finish one of those development items and moved it to the next one as I go here. So it's relatively arbitrary about how you select those work and process limits. Sometimes it's limited by resources, how many people that I have on staff who can do development. and sometimes it's based more on a feel for things. I think my team can handle about this many at a time. But you need to look at your project, at your project management tools that you have, be that Smartsheet or something else that you're using to track your resources available and who's assigned to what project, figure that out. So you want to set your work and process limits according to what you've got out there at the moment and figure out what to work on first. And the other thing you need to do is assign your resources. So how do I do this? One of the keys that I read for how to organize or how to prioritize what you're working on from that backlog or across the board is when you sit down, and probably weekly is a good time to do this, and you figure out what we're working on this week, your prioritization should take place in that backlog or in that to-do section. Right? This is your opportunity. It's not in process yet, so you can move it up or down the priority list here. But once it gets into the stream of your process, it needs to stay there and not get usurped by other things throughout that process, right? Which means you need to be diligent about planning and thinking about, in this to-do list, what's important, what should I be working on? The other one then is, how do I organize my resources for this? And I would say, again, weekly is a good time for that. Sit down either Friday afternoon at the conclusion of the week or early Monday morning and figure out, what is my team working on this week? Who's available? Who's on vacation? Who's on site? Who can help and maybe shift the roles that they normally have and do something different and unique? And the last one is, how do I maximize the resources? One of the recent things that I did was I took our junior developer, poor guy that's being made an example of here over and over again, but he's doing really well. What we did is we had a process of we're going to develop, we're going to integrate it with the rest of the software, we're going to deploy it to the PC that we're testing it on, we're going to test it there, and we're going to repeat that process over and over again for each new feature we implement on it. And one of the things I made sure of, when we first started this, I was the one responsible for building, integrating, and testing every time. So one of the very first things I taught him to do after he finished the first feature was this: okay, now, I've written a build script for you. You need to execute in LabVIEW, create an application, create an installer, take on a USB stick, install it there, and make sure it works. And we went through that process one time. And what functionally I did was cross-train my employee. Now he was no longer just a developer. Now he was a developer, he was a quality control guy and a tester, and he was somebody who could build and deploy for me as well. The next thing I did later on in the project is I taught him how to utilize the software verification plan we had. Here's a copy of it. I want you to go through it with each release and find out what works and what doesn't work as you go through it. And it was great. I never had to touch it again because he took care of that process as he went. So if you can cross-train members of your team to be functional in each of these categories, you can go a lot further in terms of making the most of that team and making sure that they're moving along quickly. Now, I need 4 volunteers quickly. I need you to help me distribute a few things around the room. Okay? So everybody wants those. I'm going to start picking names. All right, I got 1, I got 2, I got 3. I need one more. All right, right there. All right, so here's what we're going to do. No, we're not doing a magic trick. We're talking about the next concept of batching. Okay, I'm going to take this. I need you to distribute, and everybody, this may help. Oh, I'm bringing my cable with me. Okay, so I'm going to distribute these. Everybody in the room needs to get 1 sheet. Okay, everybody in the room needs to get 1 sheet. Now, these are a little bit more complicated here, but each row needs one of these decks, so don't overlap one another, right? And pass that deck to, let's go start the decks on this side. Okay, so just hand them one of those bundles of 4 cards and pass them along here. Okay. For purposes of this, try to make sure you're not sitting in a row with less than 4 people. If you're sitting in a row with less than 4 people, come forward, even just temporarily. I'm not going to do anything socially awkward to make you talk to one another, but I do want you to come forward so that you're not in a row with less than 4 people. Okay? It would be a far less exciting demonstration if we do it that way. All right. So, while you rearrange and get that done, I'll give you a minute. All right, so the concept we're going to illustrate is talking about batching. Now, in manufacturing, we talk about batch sizes, right? And we've often probably worked on control projects or things like that where we want to be able to deliver 15 of these items at a time in order to meet a throughput of so many products per hour as we go through things. And so we do things in that manner, we think of manufacturing that way. Now, the same can be true for software development. So here's what we're going to do. The rules of the game. All right, what I've distributed, 1 to each row is a stack of 4 cards. All right, perfect. So 1 to each row is a stack of 4 cards. And those cards, I believe, should be, that stack of 4 cards should be at the far right-hand side of each row. Okay? So, yep. The cards need to start over here. Last person on this side of the room. Sorry, my right, your left. So, start with the deck of cards over here, and by deck I mean 4 cards. Okay. All right. So, and then everybody's got one sheet of stickers here. Yes, right? Everybody got a sheet of stickers. Anybody need a sheet of stickers? No. Okay. If you're not participating, that's okay. You're just going to act as management and pass work along. Okay. All right. Now, let me show you where we're going with all this. If I can find my examples here. There we go. All right. So now, and then at the other end of the room, whoever is the last on that end, I need to make sure that you pull out your phone, watch whatever it is, and a just small something you can take a note on. You're going to need to take 3 notes throughout the process here. You're going to be my timekeeper for your row. Okay. All right. Now, rules of the game. So start off. Everybody who's over here who has a deck of cards in their hand, or at the end of the row, who has a deck of cards in their hand, shuffle your deck. I know there are only 4 cards. There's only 24 combinations possible. Shuffle your cards. Okay? Play along. Now, what we're going to do is your task as a developer / quality tester / whoever you are is to place one of these stickers on one card. Right? All right. Everybody see clearly here? 1 sticker, 1 card. All right. Now, first time we're going to do this through, you're going to you get your 4 cards, you're going to place a sticker on each of the 4 cards. Once you have got a sticker on every one of the 4 cards, you may pass the deck of cards to the person to your right. Okay? And you're going to pass it to that person. That person can proceed to put 1 sticker on each of the 4 cards, and when they are done with all 4 cards, they may pass it to the person to their right. All the way until you get to the timekeeper at the end of the row, and the timekeeper is going to note what time they received the deck of cards. Okay? Simple enough, right? We're timing the process beginning to end. So, and then I'll ask for times at the end, so keep track of them for me, okay? All right, so, ready? This is a bit competitive, right? I can see this, and you've got a different number of people in a row, so understand that going into it there. Question? I would say no, unless you really want to stick with the cards, in which case you can do so and count yourself in. So we've got a different number of people in a row, as long as you do it the same every time we do this. That'll work. All right, so on the count of 3, we're going to start. 1, yes, question? No, color does not matter. This is what was available at Target yesterday. So, okay. So on the count of 3, begin. 1, 2, 3, go. Start your time. Now, you cannot pass them on to the next person until you've got a sticker on all 4 of the cards in your deck. I want to think about how many other sessions this week you'll get an opportunity to play cards in. Right? It's not quite the same as gin or rummy, but gives you something to brag about. So, now, as you're doing this, think to yourself, what's it like being the one who's sitting in the development process waiting on something to do, right? What is it like handing off your work to somebody else and seeing it sit there while they work on it and seeing the rest of the line there? There's a bit of that in software development as well. I wrote this piece of software. I created the API for it. I passed it along to the next person, and now I'm watching them work on it as it goes along. So, at least I'm not holding on to the job. Absolutely. And very often, from a project perspective, I look at it with respect to a client and think the same thing. But at least I'm waiting on the client, right? However, what we'll learn a little bit, I'll discuss it later on, is very often when you get to that point, it becomes your responsibility to pull the client along too. Because you'll realize that the client turns out to be the bottleneck in some cases. And that requires a little bit of extra management to make work. All right, are all rows done? Yes? Yes? Okay, cool. So let's do this. Let's get a collective idea. I want you to call off how many seconds, or minutes and seconds, it took for your row. So we'll start row 1.
Well, it was 1 minute, 30 seconds.
Okay. Sounds good. Minute 30? Wow, moving good here. Next row. Minute 2. 53 seconds. Did I get you? Oh, okay, very good. Next row.
138.
138. 0. This is highly efficient.
64.
Not very productive, but highly efficient. What's the other one?
64.
64. Is that the last row? Okay. All right. So about a minute-ish. All right. Now pass all the cards back this way again. All right. Keep your sheets because you're going to need them. And maybe you see this coming. Okay. So let's wait till all the cards get all the way back across at the end of the respective rows. Maybe you've already done this. Are all the cards back at the end of the respective rows? Nobody waiting? Okay. So now what we're going to do is shuffle your cards again. No one's going to do the same order. And we're going to do this one at a time now. So what this means is when you begin work and you've got the stack of 4 in your hand, you place your work on the first, or place your dot on the first card, and you may then pass that card immediately to the person to your right and continue work on the other 3 that remain in the stack. As soon as they finish, they may pass it on to the person to their right, etc. Okay? Now, timekeepers, your job gets slightly more complicated this time. I need you to record 2 things. I need you to record the time at which the first card arrives, and I need you to record the time at which the last card arrives. Right? So first item delivered and the final item in the work order delivered. All right? Count of 3. We're going to start. Ready? 1, 2, 3. Begin. All the sound of the cards flipping in Las Vegas would be jealous. You, the 0 seconds, you're going to be hard to beat. So. A little bit more frantic, a little more exciting, a little less time spent waiting for your respective cards there. So, all right, let's start here because I know we're done with the first row. How long for the first card and row overall? Okay. Very good. Next row. Okay. Okay. We're getting fast here. Next one. Very fast. Next.
9 and 20.
All right.
12 and 26.
All right, very good. Pass them back here. You'll notice 2 things. One, that first card delivers generally within less than 10 seconds. The other one is it's taking us overall about half the time to get them all delivered versus the other method. So pass them all back to your left, my right. Get it back. We're going to do one more round of this. Now this one's a little bit different. I'm going to tell you something you didn't realize before, and that is that your deck has got values associated with it. So what I want you to do is I want to sort your deck from highest to lowest, right? So face cards, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. I did include aces. Aces are 1, okay? Aces are low, just to avoid any confusion there. I actually was hesitant. I almost took all the aces out of the deck just to avoid this confusion possibly. Now, what I want you to do is I need you to, when you start the process, you're going to start with the highest priority item first, and then second, third, fourth until the last item delivered, okay? So let's do this one more time. On the count of 3, 1, 2, 3. Begin. I see cards falling. It's always good. See, those are little process mishaps that happen. You know, somebody went on vacation that you weren't expecting to, or somebody stayed home sick that day. The machine broke down. You know, somebody's operating system had to be rewritten. Things like that. So, all right, and as we finish here, again, you'll note the 2 times. I didn't say it out loud, but hopefully you noted both the times. The first one arrived and when the last one arrived. All right, quickly, down the rows here. First card arrived, last card arrived. See? You're working better at it. Keep going. Very good. Next. Uh-huh. All right, very good. Very good. 8 and 24. Next row. Say again.
10 and 22.
10 and 22.
8, 20.
All right. So even if you thought you were going pretty fast the first time, you'll notice that there's a general improvement across the board. Now that represents process improvement. Part of it is looking at how the person next to you did it, looking at how the row in front of you did it. How did they do it? Did they pre-stage their 4 stickers on their fingers ready to go and just boom, 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 boom and go out that way? Or are there process improvements to be made? So talk about some of this. We discussed this earlier while you were doing it there, but what happens to other parts of the progress, or other parts of the process? When you pass it along, you're left sitting there not doing anything. So pipelining is an example of this. And we can see varying stages of benefit of this as reduce the size of the batch. Which of these 2 methods, either the large batch or the small batch, delivers something to the client first? Right? The small batches do, right? Because it can go on moving while the rest of it is working its way through. And so from a client perspective, you get early delivery. Now, for those of you timekeepers, we saw pretty obviously the time for the first delivery goes down dramatically from going large batch to small batch. How many of the timekeepers on each row respectively, just a show of hands, how many of you had a reduction in time of first delivery from the second round to the third round? Right? 1, 2, 3, 4. Okay. So there's a definite reduction in time here. I'm sorry, I may have skipped. I didn't realize no one were going across the row when I asked about time. Sorry, my bad. So Anyway, you see process improvements as you go even that way there. Okay? So one of the questions is, how do we choose what to work on first? Now, this is an example we did, only I had people flipping coins, right? I gave them a handful of coins and had them flip the coins over to their left hand and pass them around the table among 4 of us. And what you see is, the method on the far right in blue is the batch process, where nothing gets delivered until the very end, and then all of the value of the coins is delivered at once, versus delivering one at a time or prioritizing the delivery. And not only do you deliver something of higher value immediately, but you tend to deliver it sooner, partly because your process is improved and having to do that round second as you go there. So how do we pick what becomes a batch size within LabVIEW, and how do we get advantage of that? So benefits of small batches: improved quality because you're going to have an item that's got a smaller scope to it that you can test and see how it performs and find problems inside of there as opposed to trying to find a larger integrated scope of things. From the other perspective, you get early results, right? I see feedback on my process. I see feedback on the software I develop, and I know better what to do with that. I'm going to try to accelerate a little bit here because I got a feeling they're going to come knocking on the door any moment now. I do want to highlight some of this. So ideally, the best is, if we were to draw a line out of this, the ideal batch size is batch size of 1. But is that realistic, and how do I define what that batch is in LabVIEW? So what I suggest you do is think about it from an architecture and requirements standpoint. Look at the individual pieces that you have of your architecture and think, which of these could I deliver as either a standalone piece or as an additional feature to a customer? One of the most recent ones that I've done is I take and make sure that whenever we're writing something that involves data acquisition, I'll create a data acquisition class and make sure that one of the public methods of that, or one of the public items inside of that library, is a test panel that allows the user to test the I/O. Because if I'm working with a customer who's responsible for the I/O, and I'm just responsible for the software, then what I want to make sure of is that they've got all their hardware problems fixed before I come in and try to control anything, or try to log anything, or try to scale information. So I will give them that as a tool early on. That's a piece that's of value. It's not the entire project, it's not the entire solution, but it's an individual piece that has value. What if I up that game and say, okay, now I've given you that, now I'm going to give you a logging system that allows you to log data just like the final one will, but you're manually in control of everything. And now the third stage of things is, now you've got a data acquisition system and a logger in place, I'm going to give you a user interface that's a little bit fancier with that, and then I'm going to give you a control portion. Consider sectioning out pieces of your code and writing them in such a way to where they stand alone. They've got loose coupling and high cohesion, things that we strive for in software quality all the time, but deliver something that has value. So the way we think about it often when we write projects and write proposals is we say, okay, I want X% of the money up front, I want X% of the money when I complete the design, I want X% when I deliver on site, and I want X% when the verification is done. And those can be really, really long spans of time apart. And so you end up having to play games of trying to make sure those values align to cover up what your labor is going to be in the future, but not charge so much that the customer's purchasing department won't agree to it. And you go back and forth. As a matter of fact, some purchasing departments, they want to know, what are you delivering at that stage? Yes, your design requirement is complete. So we say, okay, we're delivering a design requirement. Was a design requirement worth 50% of the cost of the project? You know. So what you should do, or try to do, is think of your delivery milestones and your payment milestones in terms of the deliverable pieces of software, to where you can release something of value and get paid for that, and have something of value coming in shortly behind that and get paid for that, as opposed to holding all the cards and waiting till the end and then saying, okay, pay up, and handling it that way. Okay? You're going to not only produce a better quality item, but you're going to be able to invoice as you go. And it's a little bit different thinking, because very often we think about those traditional milestones, and if you try to tie that to lean product development and your process and think about batching and so on, the two don't match that way. So you're going to have to shift a little bit about how you write your requirements so that you can deliver packages or deliver components, and think about how you can invoice according to those. How many of you in here have a customer who would be disappointed to get something early? Right? Nobody. Chances are, if they're happy to get something early, they're also happy to authorize payment for it as well. They're not paying for the whole thing, they're paying for just the portion you delivered. So find something of value, deliver it early, and repeat that process as you go through. So how do we tell if we're being effective Was our lever pulling working properly? We've got our Kanban board and we're looking at it there. So what can we do with this information in order to be effective? So let me show you. This is, I've got one or two of them there. Yes, okay. So this is a board that I started tracking back in April for grants. And I've got my different stages of my quality management system here. And I just have a Post-it note for each of the different tasks that we're working on at the time. And as you see, we progress through here, and I'll move the notes over one to the next, and move the notes over again later on. Now this is a slow-moving project as it goes along, but one of the things to note is that if we look at this here, I've got 6 items in my development, in my right requirement section, 3 in my design, and here now I've got 5, and I've only got 2 in my design. What happened? I removed one. There's a project canceled, there's a requirement canceled, I removed it, and didn't have to do it that way. The other thing you'll notice is that things are starting to stack up in that verification one. I haven't gotten anything into the done column. What's going on right there? So how do I tell what's going on? Well, one of the ways to do that is to plot that out over time. We basically take the count of how many items are in each category on a certain date and time, and we plot it. We stack it on top of one another, starting from the earliest in the process to the latest in the process. It's basically a stacked plot. And so if you plot that over time, you can start to see trends in your data and see behaviors expose themselves. So from my perspective, I did a couple ways. You can do it in Excel where you track the date at which it finished each of these different categories as you go along, and you do a bunch of macro math to get it to figure out, okay, on this date, here's how many were in each category. Or you can just write it down here. Put a date here and put a count in each column as you go there. Then create a stacked chart in Excel. One tip is to make sure that you've got them in the reverse order in terms of the series. So sort them from the last step in your process down to the first step in your process. Otherwise, the graphic ends up getting inverted. So what I want is my last step in the process to show up at the bottom, and my first step in the process to show up at the top. And then you can start to see trends in terms of how things are going, where things are moving. So let's look at some slightly more complicated examples of it. First question, when do I update it? Again, I'd recommend weekly. If that's how often you're visiting your work and process limits and managing your resources, and if you're producing something regularly, weekly is a good glimpse to it. Now, what you may find is that your team starts to work really fast and you're not seeing a granular enough picture. You can update it daily, or you can update it just every time there's a status change on it. Right? Every time I move work from one to the next, update it. Add another date, add another time, and do it that way. Because you may find that certain processes take hours, not days, in order to achieve. Make sure it's visible to your team. Make sure they can see how they're doing. In a medical device startup company I was at, they were getting ready for an FDA audit. And there was a huge backlog, and you could see the progress of how they were ticking items off of that and the projected date at which they were going to finish it. And it was this great sense of accomplishment. There's this big 55-plus-inch TV mounted on the wall in the shop floor, and there's one mounted in the break room, and there's one mounted in the engineering department, and everybody knows where they stand. You can look at it and go, well, that's my work right there in the middle of that one there, and there's more behind it as I come along. So make sure it's visible. So I have the data. I've created a plot. How do I read this? How do I interpret it? So a couple of things to note on it. The first one is, if you look at your time from the start of the first process to the end of the last process there, that gives you the lead time of how long it takes your process to push a feature or an item through. Now, not all items are going to be the same. You get kind of a mean idea of it. But if you see that that time is getting longer the further up you move the chain, or getting shorter of the time you move up the chain, it lets you know if your levers that you're pulling are moving your process in the right direction. The other one is to look vertically on this. If you look vertically on this, the difference vertically between different stages tells you how much work and process you have. Right? And so if you see your work in process growing, it may be time to increase the limit. Or you may have exceeded a limit and you need to do something to draw that back in again. But this is your gauge that tells you how that process is doing. Finally, if you take your deployment line there, your last line, and you project it upwards and you project your backlog forward, that intersection point gives you a time on the x-axis to give you an idea of when you're going to be done implementing all of these features. So depending on it, you can track it for an individual project. You can do this at a higher level for multiple projects. Or you can just have it broken down by either an individual employee's work or a team's work. And use different variations of this in order to produce meaningful and effective information that you can use. What kind of meaningful information can we get out of this? Well, you have something that looks really complicated like this. Now this is a little bit of everything thrown into one. but it illustrates several different concepts at play. For starters, we see the growing gap between these two lines here, indicating that my work in process is growing here. Do I need to put a limit in place on it? Am I doing okay? Is that increasing work in process slowing things down or speeding things up? The dips in the line that we see, let's see if we can see, you can't see my mouse there, but the dips in the line I see in the green and blue lines indicates that work that I was working on has been moved back to the backlog. Right? I've actually reduced the work in process that I had as I went along there. Here, client removed a bunch of requirements there, and so my backlog work drops. Right? There's less for me to do, so I can see that visibly what changes as it goes. If the lines flatten, start to go horizontal, that means that I'm not producing anymore. I'm not moving more items into that. I haven't completed more items as I go. So what's happening? Is that because it's the middle of December and everybody's on vacation? Or are we stuck? Are we spinning our wheels stuck on a particularly bad development process as we go along there? You remember my example of the post-it notes that I have on the whiteboard? I said everything kept getting stuck at verification there. And so what you would see if you look at a chart of mine is that the verification line just kind of flatlines. It sticks there and proceeds to not move. And the reason why? The customer was the one responsible for building the hardware. And as we released software, they were finding out there were leaks in the hardware, and they have to go back and redesign the hardware, which means we had to redevelop the software, and so on and so forth. So as you go through that, you're going to start to realize it makes things more visible for you. So again, track it weekly or track it as things occur. So what now? All right? There's a bunch of information thrown at you. And again, I took a 1-week course and tried to condense it to the 4 or 5 items that I found particularly interesting, particularly applicable for me. So what I encourage you to do is take from that list of things that we've covered in terms of teamwork and in terms of work and process limits and tracking cumulative flow and things like that, and find 1 or 2 that you think might be useful to you. Maybe it's just going back and identifying your process levers and gauges and figure out how am I going to manipulate my process, how am I going to measure how I'm doing. Find one of those, find an accountability partner. Maybe they're here in the room with you. I got less than a minute. So maybe they're here in the room with you. Maybe it's somebody you go back to the office and talk to your manager or talk to a coworker who's also responsible for this and say, look, I want to try something. And explain what it is that you're trying. Talk about the card game. Talk about batching, things like that. But come at it and walk away with something you're going to try new. Maybe it's just create a Kanban board at the end of the day. But walk out and try something new. And then finally explain what you're about to do. Make sure that everybody's on board. All right. So we're at time here. What I would encourage you to do is please take the survey. If you didn't scan your badge on the way in, make sure you scan it on the way out for them. I appreciate your time today, and hopefully we're not too late. We're about right on time. So enjoy the rest of your day. Thanks again for the time, and y'all have a great one. All right, thank you.